Imagine a world where rivers flow with liquid methane, rain falls from orange skies, and icy landscapes stretch as far as the eye can see. This isn't science fiction. It's Titan, Saturn's largest moon, and one of the most Earth-like places in our solar system. But how much do we really know about this alien world? Let's dive into the story of the Huygens probe, humanity's first and only landing on Titan, and uncover the secrets of this frozen, mysterious moon. The boundary between moon and planet is complicated on Titan. To begin with, there's a good reason it's named Titan. It's bigger than Mercury, the smallest planet in our solar system, and one of just 2 moons like it. It also has the thickest atmosphere of any of the almost 300 moons in our solar system. Titan has 1.5 times the atmospheric pressure of Earth. The fact that it orbits Saturn rather than the Sun is the sole criterion that disqualifies it as a planet. Titan is perhaps the most Earth-like planet in our solar system due to its alluring traits, with the exception of its temperature. On Titan, the temperature is usually minus 180 degrees Celsius. Because of the extremely low temperatures, water ice is used as a substitute for rock, and liquid methane for water. We can tell that the resultant scenery is disturbingly familiar though. While Titan's surface is a frozen, hydrocarbon-rich landscape, scientists believe that beneath its icy crust lies a vast subsurface ocean of liquid water. This ocean, kept liquid by the heat generated from Titan's gravitational interactions with Saturn, could be as much as 50 miles deep. But what makes this ocean so intriguing is the possibility that it could harbor life. Not as we know it, but life that thrives in extreme conditions. On Earth, we've discovered microorganisms living in the most inhospitable environments. Deep-sea hydrothermal vents, acidic hot springs, and even within glaciers. These extremophiles have shown us that life can adapt to conditions once thought impossible. Could Titan's subsurface ocean host similar organisms? The answer lies in the chemistry of this hidden world. Titan's ocean is likely rich in ammonia, which acts as an antifreeze, keeping the water liquid even at extremely low temperatures. This ammonia-rich environment, combined with the presence of organic molecules on Titan's surface, could provide the building blocks for life. But it wouldn't be life as we know it. Instead, it might rely on chemical reactions we've yet to fully understand. A form of life that doesn't need oxygen or sunlight to survive. One of the most fascinating aspects of Titan is its methane cycle, which mirrors Earth's water cycle in many ways. On Titan, methane rains from the sky, fills rivers and lakes, and evaporates back into the atmosphere, creating clouds that will eventually rain again. This cycle is driven by Titan's complex weather systems, which include methane storms, winds, and even seasonal changes. But why methane? On Earth, water is the solvent that facilitates chemical reactions necessary for life. On Titan, methane plays a similar role, albeit at much colder temperatures. This raises an intriguing question: could a methane-based ecosystem exist on Titan? Scientists have theorized that methane-based life forms, or methanogens, could potentially thrive in Titan's lakes and rivers, using methane as both a solvent and an energy source. While we haven't found evidence of such life yet, the possibility is tantalizing. If life can exist in Titan's methane lakes, it would fundamentally change our understanding of biology and the conditions necessary for life to arise. On January 14, 2005, the Huygens spacecraft made history by touching down on Titan, marking the farthest landing ever achieved by humanity. But what did we learn from this daring mission? And what happened to Huygens after its brief moment in the spotlight? Titan is no ordinary moon. It's bigger than Mercury, has a thick atmosphere, and features a methane cycle eerily similar to Earth's water cycle. Methane rains from the sky, fills rivers and lakes, and evaporates back into the atmosphere. But with temperatures plunging to 180 degrees C, water ice replaces rock, and liquid methane takes the place of water. Huygens, built by the European Space Agency, hitched a ride on NASA's Cassini spacecraft, which launched in 1997. After a 7-year journey, Huygens separated from Cassini and began its descent. The probe was equipped with a heat shield and parachutes to slow its fall. But no one knew exactly where it would land. On a mountain, a frozen plain, or even a methane lake. The probe was about 2.7 meters 9 feet wide and weighed roughly 318 kilograms and 700 pounds. It was built like a shellfish. A hard shell protected its delicate interior from high temperatures during the descent through the atmosphere. The probe had 2 parts: the entry assembly module, and the descent module. The entry assembly module carried the equipment to control Huygens after separation from Cassini, and a heat shield acted as a brake and as thermal protection. The descent module contained the scientific instruments along with 3 different parachutes that were deployed in sequence to control Huygens' descent to the surface of Titan. It appears that the landing was actually rather cordial. Without a hitch, the parachute deployed, and Huygens sank to Earth with the same slowness as a ball dropped from a hand-held height. The entire drop lasted almost 2.5 hours. After making a 12-centimeter crater on the moon's surface, Huygens bounced and skidded 30-40 centimeters across the frozen ground before coming to a stop. Now that it had safely reached the surface, the probe could begin to explore its new environment. Ground winds of a few meters per second whipped Huygens about. In the blink of an eye, it captured a famous photo, an unsettling picture of a faraway planet that was both familiar and strange. Just below the image's center are 2 rock-like items with diameters of approximately 15 and 4 cm, respectively. Despite this, they are filthy clumps of water ice, not rocks. The cold stones appear to have been ground, maybe by a trickling stream. Huygens ended up on a dried up river, which means it was once a river that frequently rained liquid methane from Titan's massive atmosphere. Huygens's data had to be gathered as soon as possible. Titan's extremely feeble light and short 3-hour battery life meant that solar power was not an option. Mission controllers initially believed the probe's power would be consumed by the landing. Initially, only 30 minutes of ground-based observations were planned before landfall. In the end, Huygens played a remarkable 72 minutes. The data was acquired by the orbiting Cassini and sent back to Earth, where scientists are eager to analyze it. It is still challenging to forecast Huygens's present state, even after 20 years. It could be covered in silt or washed away in a flash flood. Because the sun's rays are so faint, it takes an extremely lengthy time for liquids to evaporate off the moon's surface. There is a negligible amount of liquid that evaporates here compared to Earth, just around 1 centimeter each year. Titan, in contrast, has an atmosphere that is thick enough to contain hundreds of times more liquid than Earth's. That is to say, the rain clouds on Titan take an extremely long time to build, but when they break, they unleash an enormous amount of liquid. This could lead to extremely uncommon occurrences like flash floods and torrential rainfall. Even if it hasn't happened yet, Huygens's riverbank home will inevitably be flooded in the future, because these events could happen decades or even centuries apart. Despite Titan's awful environment, Huygens is probably still intact and unharmed. The sturdy and long-lasting metal frame is likely unbroken. However, because to the cold conditions, the inner components, including electronics, insulation, parachutes, and others, would have begun to degrade, perhaps becoming brittle and stiff. The probe eventually becomes a frozen and aged artifact as it fades into its surroundings over time. Assuming this hasn't occurred already, Huygens will presumably be engulfed in hydrocarbon mud, partially preserved but permanently trapped on Titan, over the period of decades or centuries. The success of the Huygens mission has certainly whetted astronomers' appetites, and there's a growing clamor to return to Titan. NASA plans to launch the Dragonfly mission in 2028, hoping to arrive at the giant moon in 2034. It is a robotic rotorcraft, a bit like a helicopter, and its successful deployment would mark the first powered flight on a moon. It could take off and land many times, allowing it to explore multiple sites rather than the solitary location available to Huygens. A big part of the Dragonfly mission will be astrobiology. If Titan really is the most Earth-like place in the solar system, how similar is its chemistry? Does it have the necessary biological building blocks for life? And has it ever had the right conditions to put them together? Titan's unique environment makes it one of the most promising places in our solar system to search for extraterrestrial life. But it's not just about finding life. It's about understanding the diversity of life. If life exists on Titan, it would likely be fundamentally different from life on Earth, challenging our assumptions about what life is and where it can exist. This has profound implications for our search for life beyond our solar system. If life can arise in the methane lakes of Titan, it could also exist on exoplanets with similar conditions. Titan serves as a model for how life might develop in environments vastly different from Earth's, expanding the range of potentially habitable worlds in the universe. Titan is often described as a frozen time capsule because its conditions may resemble those of early Earth. Before life arose on our planet, Earth's atmosphere was rich in methane and nitrogen, much like Titan's today. By studying Titan, scientists hope to gain insights into the chemical processes that led to the emergence of life on Earth. For example, Titan's atmosphere is filled with complex organic molecules, including hydrocarbons and nitriles, which are the building blocks of proteins and DNA. These molecules are created when sunlight interacts with methane in Titan's upper atmosphere, producing a thick haze that shrouds the moon. Studying these processes could help us understand how similar molecules formed on Earth billions of years ago, setting the stage for the origin of life. As we continue to explore Titan and other potentially habitable worlds, we must also consider the ethical implications of discovering extraterrestrial life. How would such a discovery impact our understanding of ourselves and our place in the universe? Would it unite humanity in a shared sense of wonder, or would it raise new questions and challenges? Moreover, if we do find life on Titan, how should we proceed? Should we attempt to study it in its natural environment, or should we bring samples back to Earth? These are questions that scientists, ethicists, and policymakers will need to address as we venture further into the cosmos. Titan is more than just a moon. It's a testament to the boundless complexity and diversity of the universe. It challenges our assumptions, expands our horizons, and reminds us that there is still so much to discover. As we continue to explore this enigmatic world, we are not just uncovering the secrets of Titan, we are uncovering the secrets of life itself. So, what do you think? Could Titan be the key to unlocking the mysteries of life? Let us know in the comments below. And don't forget to like, share, and subscribe for more deep dives into the wonders of the universe. Until next time, keep exploring.